To finish off our topic of planning, we're going to talk about how to convert a problem into a planning problem to constraint satisfaction problem. So far, we've looked at forward planning. So in forward planning, we consider the nodes considered constrained to be reachable. So we're only considering paths from the start. So all the paths, all the nodes which are states are reachable, even if they don't lead to a goal. In the other way we've looked at is regression planning. The nodes are constrained to be ones for which we can achieve the goal, even if they're not reachable. So there might be some sub-goals which we cannot actually reach. So what we're going to do is we're going to look at constraint satisfaction problems. We're going to constrain the state by both the starting state and the goal. However, we can only do this if we know the number of steps. So what we're going to do is we're going to look at searching over the planning horizon. The planning horizon is the number of time steps. And for each planning horizon, we construct a constraint satisfaction problem constraining possible actions and features. So we're going to have all these constraints that constrain what we can do in here. So here's what we're going to do. So we're going to choose, in the constraint satisfaction problem, we're going to choose the variables, we're going to choose the constraints. So what we're going to do is we're going to choose a planning horizon K, and we're going to construct a variable, create a variable for each state feature from time 0 to K. So for each state feature, there's going to be K plus 1 different variables. And then for the action variable, there's going to be K action variables, one for each of the time from 0 to K minus 1, because we're going to do K planning horizons, a number of actions. So here's an example of doing this. So we're going to have two time horizon of 2. So we're going to have the robot's location at time 0, the robot's location at time 1, and the robot location at time 2 are going to be different variables. So we've got 3 variables for the robot location at every time. And then we have a variable for the action at every time. Okay, and the robot location at time 1 depends on the robot location at time 0 and the action at time, what the action was. And the action at any time 0 depends on what's true in that time. Okay, so we've got these are the actions. So they're the value for actions, and the value for the locations is this is a value with rlock1, 0 is a variable with 4 values, and all the others are Boolean, except action 0 has 5 different values. Okay, so the sort of constraints we have are precondition constraints between state variables at time t and action variables at time t. Specify the constraints of what actions are available to the state. So this action here, there's a constraint between what action can be carried out in the location. There's a constraint between what action can be carried out and whether the robot has coffee. So some of the actions are dismissed about when the robot has coffee or not. So whether your robot can pick up coffee depends on whether the robot has coffee. Whether the robot delivers coffee depends on that. Okay. So the other ones we have is effect constraints between a state variable at time t and action variables at time t and the state variable at time t plus 1. These constrain the resulting state to be one that satisfies the effects. So if we look at here, this is going to be an effect that says, here's how the location depends on the previous location and the action. That's going to be this constraint. This is going to say whether the robot has coffee at time 1 depends on the action about whether it was deliver coffee or pick up coffee, and also whether the robot has coffee before. Okay, so that's the effect constraints. There's also frame constraints, because we also have to say some of the times things don't change. We also have to model that as part of another constraint. The value was the same as before if it wasn't on the effects list. And then we have initial state constraints that are usually typically domain constraints are the initial state. So we typically say what to know that's true. And goal constraints that constrains the final state to be a state that satisfies the goals that are to be achieved. So here are some example constraints. So you can say if the action is pick up coffee, then the precondition says that the location has to be the coffee shop if the action is pick up coffee. And so that one is violated when we have the robot location is not computer coffee shop and the action is pick up coffee. So that's what we're going to do in here. We're going to talk about, here's a constraint saying it's not the case that this is true. Okay, the effect constraint that says the robot has coffee at time I plus 1 if the action was to pick up coffee. So that's violated when the robot has coffee is false and the action is pick up coffee. So we're going to talk about, so we can do, these are all become constraints. So these are not allowed to be violated. So robot has mail at any time it had mail before, and the action wasn't to pick up mail or deliver mail. So the robot has coffee at time I plus 1 if the action is not pick up mail and deliver mail, and the robot has coffee at, the robot has mail at time I. Okay. Now, this is violated when the action is different to pick up mail, the action is different to deliver mail, and these two are different. So we have this cases about where we're going to have these frame constraints as well. Okay, so what we'll do is in class, we'll show you, we'll try and compare this to the other ones and show you how this works. Okay, thank you all.